Hi children, today we are going to start the second video of the topic integration. In last topic, we have stopped our video from the point of identifying the constant c in an integration. We know that we have to add a constant c at the end of any kind of integration. What are the use of having this c? I told you that I'll be continuing that topic from today's video. Our problem was, if you differentiate x cube plus 3x squared minus 25x, or if you differentiate x cube plus 3x squared minus 25x plus 5, whatever the way, you get the same answer, 3x squared plus 6x minus 25. That means if you integrate 3x squared plus 6x minus 25, what would be our answer? Whether it's x cube plus 3x squared minus 25x or x cube plus 3x squared minus 25x plus 5. Let's try to understand in this way. If we consider y equals to x cube plus 3x squared minus 25x at a point x equals to 1, it passes through the y value of minus 21. That means if you substitute x equals to 1 into the equation y equals to x cube plus 3x squared minus 25x, you receive the y coordinate where it passes through. You will receive the answer minus 21. Therefore, this equation or the curve y equals to x cube plus 3x squared minus 25x passes to the point 1, minus 21. Then we will consider the second equation, y equals to x cube plus 3x squared minus 25x plus 5. If you substitute the same x equals to 1 into that equation, you receive the answer minus 16. That means the curve y equals to x cube plus 3x squared minus 25x plus 5 passes through the coordinate 1, minus 16. We use this logic to understand the real equation formed after an integration. From this diagram, we can verify that fact. Therefore, if you integrate 3x squared plus 6x minus 25, you will receive y equals to x cube plus 3x squared minus 25x plus 5, or y equals to x cube plus 3x squared minus 25x. If it is y equals to x cube plus 3x squared minus 25x plus 5, it should travel through the coordinate 1 minus 16. If the answer is y equals to x cube plus 3x squared minus 25x, it will travel through the coordinate 1, minus 21. Now let's try to understand the concept from this question. Example 1 says, given that the gradient function of a curve y is dy by dx equals to 3x squared plus 6x minus 25. And specifically they mention the curve passes through the point 1, minus 16. Our problem is to find the equation y. From the previous theories, we know that if you want to find y, the main equation, from dy by dx, the gradient equation, we need to integrate it. The relationship is, if you get a function fx or y, if you differentiate it, you get dy by dx or the gradient function. The opposite operation of the differentiation is the integration. Then if you integrate the gradient function or dy by dx, you receive the original function y. Therefore, you can understand that if you want to obtain the original function y, we need to differentiate the answer for dy by dx. Therefore, let's try to integrate 3x squared plus 6x minus 25 dx. Hopefully you can understand the integration part, and we'll obtain the answer x cubed plus 3x squared minus 25x plus c. If you have any doubt how to integrate this question, you can refer into my first video, Integration for Beginners Part 1. You can understand that at the end of this integration I have added a plus c, because we know that from our previous theory, depends on the point it passes through, the coordinate may be varying, or the plus c value may vary with the question itself. Then how to find this value of c? They have given us the curve y passes through the coordinate 1, minus 16. That means when x coordinate is 1, you should receive the y answer as minus 16. Therefore, you can write minus 16 is equals to 1 to the power 3 plus 3 times of 1 to the power 2 minus 25 times of 1 plus c. If you simplify this, you will receive the answer c as 5. That means the equation y, you can write it as x cube plus 3x squared minus 25x plus 5. Hopefully you can understand how to find the value of c in an integration problem. Let's try to verify the theory from our second example. The question is, they have given us the gradient function dy by dx 4x cube minus 6x squared plus 6x minus 2. And they have given that the curve passes through the point 2, 9. We need to find the original equation y. Okay, let's try to map to the answer. Then if you want to get the answer y, we need to integrate the dy by dx function. Therefore, to obtain y, we need to integrate 4x cube minus 6x squared plus 6x minus 2 dx. The integration of 4x cube minus 6x squared plus 6x minus 2 would be x to the power 4 minus 2x cube plus 3x squared minus 2x plus c. Then our objective is to find the value of c, the constant c added to this expression. They have given us as excess information the curve y passes through the coordinate 2, 9. That means when the x coordinate is 2, the y coordinate becomes 9. Therefore, you can write 9 equals to 2 to the power 4 minus 2x to the power minus 2 times of 2 to the power 3 plus 3 times of 2 to the power 2 minus 2 times of 2 plus c. That means when y equals to 9, x coordinate turn up into 2, as you mentioned in the previous example as well. If you simplify this, you receive the answer c equals to 1. Therefore, the original equation is y equals to x to the power 4 minus 2x cube plus 3x squared minus 2x plus 1. Hopefully you have enjoyed my video.